Assalamu alaikum everyone. Today we are going to start paper May June 2023 paper 2-1. Okay. So question number 1. And this from 2023 onwards, there is a new format of 80 marks and you have to attempt all the questions. Now question number 1. Choose from the following oxides to answer the questions. Okay, let's recall about oxides first. There are four types of oxides: acidic, basic, amphoteric, and last one are neutral. I think my screen is stuck. Just wait for a minute, please. Yeah. So, what are acidic oxides? If you recall, all non-metal oxides, when the non-metal elements bond with the oxygen, form non-acidic oxides, but there is an exception. And what are those exceptions? That dinitrogen oxide, CO, and H2O. In the same way, when we talk about basic oxides, all metal oxides with the metal elements bond with oxygen to form metal oxides, with the exception of there are three exceptions, except ZnO, Al2O3, lead oxide. Then the amphoteric are the one which shows both acidic and basic nature. And the amphoteric oxides are water is an amphoteric oxide, zinc oxide, aluminium oxide, and lead oxide. These all are considered as a amphoteric oxide. Then we have neutral oxide, means they are neither acidic nor basic, right? So the examples are dinitrogen oxide and carbon monoxide. Is this understandable to all of you? No, these are not salts. Salts are, they have any other negatively charged ion, but not oxygen. Okay. Each oxide may be used once, more than once, or not at all. So this statement is explaining this, that it's not necessary that every formula that is written over there must be used. So might be there are some oxides which can be used more than once, and there are ones which cannot be used at all. Okay. Khatija, unfortunately, you are wrong. Fe2O3 is the oxide. Yes, okay. Now am I audible, Moise? Mustafa, you are also wrong. Okay, state which oxide. A is a solid made during the thermal decomposition of limestone in blast furnace. So if you recall, limestone is a calcium carbonate, which is an ionic compound. And when we heat it, two oxides are formed. One is calcium oxide and the other one is carbon dioxide. Both are oxides, but carbon dioxide is a non-metal oxide, and we all know that carbon oxide is a gas. Yes, Rahim, very good. Calcium oxide is a ionic compound, so it's a solid. So answer for this one is a solid. It's the solid one is a calcium oxide. Is this clear to all of you? Fe2O3 could not be answer because Fe2O3 is oxide which is already present in its ore, and we have to extract the iron from that ore, it is not formed during the extraction or during the blast furnace. Is this clear? Reacts with both acidic and alkalis, it means it's an amphoteric one, and we have just discussed that there are 4 amphoteric ones. Okay. So yes, we are going to write aluminum oxide, the first one. Has a giant covalent structure. So among these, which one has a giant covalent structure? Very good, Rahim. Very good, Wara. Very good, Mustafa. Very good, Khatija. So it's a silicon dioxide. So if you see, this one is ionic, this one is ionic, this one is ionic, this one is ionic. These are covalent, 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 covalent. And this covalent is giant. The other covalents are simple molecules. Okay. Now, has an ion with an oxidation number of +2. Okay. So among these, which one has an ion with the oxidation number of 2? Very good, Rahim. It's calcium oxide. As you see, there is no charge on it. So which means whatever the charge on calcium and on oxygen, the sum of those charges are 0. And if you look in the periodic table, you will find oxygen. It's in group 6. It means it has a -2 charge, right? So it's -2 and the net charge is 0, which means calcium must have a +2 charge. So the answer is CaO. Now, turns white anhydrous copper sulfate blue. Yes, which oxide does? Very good, Abdul Hadi. Yeah. Yes, Rahim. Very good, Vara. Yes, Rahim, we can write it twice. See, they have mentioned over here, each oxide can be used once, more than once, or not at all. Yes, Mustafa. Yes, Kamar. Very good. So the oxide which turns white anhydrous copper to sulfate to a blue makes it hydrated, and it happens due to the as the calcium sulfate absorbs water. So it means it's a water H2O. It's an oxide which does this. Okay. Now, next one is made during the fermentation of aqueous glucose to make ethanol. Yes. Which oxide is formed when the glucose is fermented? Can anyone recall the equation? Yes, very good, Zainab. It turns to form 2 moles of ethanol and 2 moles of carbon dioxide. So see, this is the oxide. Yes, very good. So it's carbon dioxide. Walaikum assalam. Okay. Now, next question. Question number 2. Group 1 includes the elements lithium, sodium, and potassium. State 2 physical properties of lithium. Yes, who is going to tell me the correct physical properties of lithium? It's a group 1 metal. So, wrong, Khatija. It's a group 1 metal, and group 1 metals are soft metals, so they always have a low melting point. Just give me a minute, please. Yes, I got some answers. Yes, Ahmed Mujtaba, you are correct. Khatija, yes, this time you are correct. Zainab, you are correct. Vara, you are wrong. If they are soft, then their density, it could be high. Yes, Kamar, very good. So you can write soft. You can write low melting point. Okay. Beside this, you can further write good conductor of heat. You can write good conductor of electricity. But they didn't ask you the trend, Rahim. It's a trend. They just ask you the simply the properties of lithium. So you have to just write two properties. It can be a malleable. You can write malleable because it's a metal. You can write ductile. It's a metal. You can write it's shiny. That is a metal. But when we talk about the density and melting points, as they are soft metals, so you have to write its low melting point and you can write it soft. You can't write its density is high, its density is also low. As it's, there is observation that it floats on water, the group one elements. Okay, now, next part. Potassium reacts with a cold water. The ionic equation for the reaction is shown. Okay. State in terms of electrons why potassium is a reducing agent in this reaction. Yes, what is the reducing agent? Reducing agent, yes, very good, Khatija, because itself it is oxidized. Yeah, very good. It undergo oxidation. And if it undergo oxidation, how can we prove that it undergo oxidation? It is oxidized. Yeah, it oxidizes another compound. No, it doesn't. Sorry, Zainab, it's a reducing agent, so it reduces another compound. Itself undergo oxidation. Vara, oxidation is a loss of electron. Oxidation is not a gain of electron. So what does +2 charge means? And it's not +2, it's a +1 charge over here, right? And here it's 0. So it means that it lost its electron. It loses its electron, right? It is because, see, why I am talking about the electrons? Because they have told you that state in terms of electrons. So we have to write in terms of electrons only. So I am going to write that it is because it loses electrons. Is this clear to all of you? Yeah, oxidation occurred. But if you write that it is because potassium oxidized, you will not get any mark because they have asked you to state in terms of electrons. So how can you define oxidation in terms of electron when the electrons are lost, right? Okay, next part. State the oxidation number of hydrogen in H2. Yes, very good. It's an element. Yes, Khatija, Abdul Hadi, Rahim, very good. So its oxidation number is 0. Describe what is observed during this reaction. Very good. Physis, colorless gas. Solid disappears, but it's a group 1. So we are, yes, container heats up. Very good. So it floats on water, the group 1 elements, right? So in water, you are going to observe that it floats on water. It's for 3 marks, right? So you have to write three observations. Physis, and what else you guys have written? And further, due to the heat, as the reaction is exothermic, we observe that potassium melts. And another observation can be, yeah, we have written physis, right? So physis means that there is a bubbles of a colorless gas, Rahim. Okay, further we can make the solid disappears can be a correct and it forms a solid solution, colorless solution. Yes, lilac flame can be written because it catches the fire. So when it catches the fire, the potassium burns in a lilac flame. Now, A sample of sodium chloride is tested using a flame test. State the color of the flame test seen in this test. Yes, Yusuf, very good. It's a yellow. So see, these tests are provided to you in the paper 4. All the cations, anions, gases test and the flame test, but these tests are not going to be provided in paper 2 and paper 1. For these, you have to remember all the gas tests, all the cations test, all the anions tests, and all the flame tests. Okay. Now, question number 3. This question is about the preparation of salts. Zinc chloride is a soluble salt. Okay. Okay, if it's a zinc chloride, can anyone recall, as we have discussed the methods, by which method we can prepare zinc sulfate, zinc chloride? The most appropriate method is one when we react zinc oxide with the HCl, right? And it's a insoluble solid and it's a solution. So that's what they have written, insoluble base. So this is an insoluble base and a dilute acid. Is this clear? By crystallization, we get the crystals which are soluble in water, but initially it is formed in the aqueous state. See the equation. We are getting zinc chloride aqueous. The equation for this reaction is shown. Okay, a sample of 3.50 gram of oxide is added to 50 centimeter cube of 0.12 mole per dm cube hydrochloric acid. Show by calculation that zinc oxide is in excess. So see, they have told you that zinc oxide is in excess. So as I have told you, for the limiting reactant or the excess questions, you are provided with the amounts of both the reactants. So first you need to convert these amounts. So I have given with the mass of zinc oxide and I have to find the moles of zinc oxide. So what I will do, for moles of zinc oxide, I have to use the formula mass upon MR. So 3.5 is the mass. What is the MR of zinc oxide? Oxygen is 16 and zinc is 65. So 65 and 15 is 80 and 81, right? So 3.50 divided by 81. Can anyone tell me the answer, please? Then we have to find out moles of hydrochloric acid as well. And we are given with the volume and the concentration of hydrochloric acid. Yes, can anyone calculate it and tell me the answer, please? Okay, thank you, Zainab. It's 0.043. Okay, now the moles of hydrochloric acid are calculated by multiplying its concentration, which is 1.20, times its volume, which is 50. It's a centimeter cube and we have to convert it into a decimeter cube. So we might divide with the 1000. Can anyone tell me the moles of HCl? It's 0.06. Okay, thank you, Abdul Hadi. So we got the moles. So these are the moles amount in moles of both the substances which are given to us, right? Now, I am provided with the mole ratio because I have a balanced equation. So I'll use that. I'll take the ratio of zinc and hydrochloric acid. From the equation, we see, sorry, zinc oxide. There is a 1 mole of zinc oxide and there are 2 moles of hydrochloric acid. So, as we have to find zinc oxide in excess, so I make zinc oxide X, also I am given with this amount, but this is the given amount. I made this exit C, Kamar, this is the concentration of hydrochloric acid, right? And here we got the volume of hydrochloric acid. So if we are given with the concentration and the volume, we use the formula concentration times volume, and that volume must be in decimeter cube. So this volume is in centimeter cube. That's why we have divided it with the 1000. Okay. So the moles of hydrochloric acid we have is 0.06. Now, the moles that the X moles that I am going to get over here is a required moles that are, or you can say these are the moles which are needed. So now you get to know, let's find the moles which are needed. So 0.06 divided by 2. So what is the answer? 0.03 moles, and these moles are of zinc oxide, right? And these are the moles of zinc oxide which are required or needed. Is this clear? Yes, still here, is this clear? No, yeah, you can compare them with the mass as well, but you can compare them with the moles as well. It's up to you. So see, how many moles are given to us for a zinc oxide? 0.06 moles of zinc oxide are given to us. And how many moles are actually needed? 0.03. Yeah, sorry, it's of HCl, my bad. The moles of zinc oxide are 0.043 are given to us. Yes. And the moles that we need for this reaction is 0.03. So the moles that are needed are lesser than the one which are provided to us. So it means it is in excess, isn't it? Is this clear to all of you? So zinc oxide is in excess as only 0.03 mole are needed, but 0.043 moles are provided. Is this clear to all of you? If anyone has any confusion, any question, please ask. Yeah, it's very appropriate if you will write the statement. That examiner must know that you will be very clear. Now, next part, state why it is important to use an excess of zinc oxide in this preparation. Yes. Yes, who is going to tell me the answer? Okay, as you see the equation, so all of no, what is the benefit of being amphoteric? See, HCl is an is aqueous, right? So it means we have a container, and in container there is a HCl, and I am going to put a solid zinc oxide in it, right? So if zinc oxide is in excess, what will happen as the reaction will finish? Some of the zinc oxide left behind, and all of the acid which is in aqueous must be used up. That's why some of the zinc oxide left behind. So at the end, we are getting only zinc chloride and water. So we can easily able to separate zinc chloride from the water. But think, if you have chosen the lesser amount of zinc oxide, that is a solid. So what happens? All the solid will dissolve. So if all the solid will dissolve, so it means some of the HCl left behind. So when the reaction is ended, we have a HCl in the solution, we have a zinc chloride in the solution, and we have a water in the solution. So water can be evaporated, but how can you separate these two? So you are not going to get the pure crystals of the salt if zinc oxide is not in excess. Is this understandable? So that's why we use a solid in excess. So to make sure that whatever the reactant that is present in the aqueous state, that all of its amount must be used up. So we are left with only the products, and none of the HCl in the aqueous must be left behind. Yes, very good, Zainab. So is this clear to all of you? It is to ensure that all of the acid is used up. Yes, if any one of you has any confusion in it, please ask. Next part. Suggest how the excess zinc oxide is removed from the reaction mixture to leave only aqueous zinc chloride. So I think it's very easy. It's a solid, and to solid, If we have to remove the solid, what we will do? Yes, we will do the filtration. Very good, Zainab and Heather. Now, barium sulfate is an insoluble salt. It is prepared using precipitation method. That's what we have discussed. Name two aqueous solutions that react together to give the barium sulfate precipitates. Okay. So if you see barium is in group 2, so it's a +2, and sulfate is in, so it's a -2. So we need this barium sulfate, and it's a water insoluble salt, so it forms as a solid. Very good, Rahim. Very good. So we need two substances. One contains barium and it must be aqueous, and one contains sulfate that must be aqueous too. Yes, very good, Zainab. So see, you have to remember the solubility for this. So if you recall that all the substances containing, all the compounds containing nitrate are water soluble. So nitrate has a -1 charge, barium has a +2 charge. So it means we need a barium nitrate, one thing. Sulfate. So it's very easy to recall the sulfate, that which sulfate we can use. For example, you can take a acid, the acid which contains a sulfate is a sulfuric acid, or instead you can use any group 1 metal, because all the group 1 salts are water soluble, like sodium sulfate, lithium sulfate, potassium sulfate. So it's not necessary that you use sulfuric acid only. Instead it you can use lithium sulfate. Instead it you can use sodium sulfate. All of them are water soluble because they contains group 1 in it. Okay. So name the two aqueous solutions. So one aqueous solution is barium nitrate, and the other aqueous solution is either sulfuric acid or lithium sulfate or potassium sulfate or sodium sulfate. You can use any. Okay, very good, Rahim. See, if you do this, instead of writing the for names, you will write the formulas. So there is a high chance that most of the students do this mistake. Instead of keeping twice, they just write BaNO3. Now, another thing. Now it's up to examiner, because examiner has asked you to write the name, not the formula, right? So now it's up to examiner whether examiner go consider them correct or mark them wrong. It's up to the examiner. So you have to be very careful about the instructions what is provided and follow those instructions only. If they ask you to write the name, write the name. If you ask you to write the formula, write the formula. Yeah, the places can be swapped. You can write sulfuric acid first and barium nitrate later. It doesn't matter. Now, next part. Sodium nitrate is a soluble salt. Okay. It is prepared by the reaction of an acid and an alkali. So see, nitrate, it means what acid it would be? Nitric acid. And sodium nitrate. So which alkali it would be? Sodium hydroxide. And again, they have asked you to write the name. So you will write the name over here. Nitric acid and sodium hydroxide. Both are alkali, both are aqueous solution, and we are preparing the soluble salt, right? Name the experimental technique used to make neutral aqueous sodium nitrate. Yes, by which technique we can uh, make, we can prepare this salt when the both the acids and alkali are used. Very good, Zainab. It's titration. Yes, very good, Heather. Very good, Ahmad. Very good, Rahim. Okay. Now, question number 4. This question is about compounds that contain phosphorus. Okay. The formula of the phosphide ion is, okay. Complete table 4.1, show the number of particles in the phosphide ion. So here I am writing it. P phosphide ion is having a 3 negative charge and 15 and 31. So how many electrons it has? 18 electrons, very good. 16 neutrons, very good. And how many protons it has? There are 15 protons, 18 electrons, 16 neutrons, and 15 protons. So protons would be like this. For neutrons, we have to subtract 31 minus 15. And as there is a 3 negative charge, so 15 plus 3 is 18. That is the number of electrons. Is this clear to all of you? Now, state why the formula for phosphide ion is P3 negative rather than P2 negative or P4 negative. Yes, because it gained 3 electrons to complete its outer shell. Very good. Yes, Heather and Rahim. So, it gains 3 electrons to form P3 negative and it has completely filled valence shell when it's P3 negative only, because it becomes P2 negative, it has a space for 1 electron in the valence shell, and if it becomes P4 negative, it has a space for 7 electrons. Okay. Yes, very good. No, you can't say it's oxidation number because you have to justify it. If P2 negative, then 2 negative is the oxidation number. If it's P4 negative, it's the oxidation number. So they are asking why P3 negative only, why not P2 negative or P4 negative? It is because that only in this, when it is become P3 negative, then it has then its outermost electron shell is completely filled. Okay. The formula of the calcium ion is Ca2 positive. Reduce the formula of calcium phosphide. Okay, so calcium is 2 positive and phosphide is 3 negative. So you know the rule when the charges are different. Yes, very good, Heather. Very good, Zainab. So we will swap the values of the charges in the subscript of the opposite ion. So I'm going to write 3 over here and 2 over here. That will be the formula of calcium phosphide. Yes, very good, Rahim. Now, D part. Calcium phosphate is an ionic compound. Explain why calcium phosphate has a high melting point. And it's of 2 marks, right? So remember, whenever the examiner asks you and tell you about with any formula. Yes, Ahmed and Rahim, very good. But Rahim, your answer is incomplete. Now your answer is complete. Heather, your answer is also incomplete. And Ahmed, your answer is also incomplete. The answer you guys gave me, all of you will going to give you score only 1 mark out of these 2. Yes, very good, Abdul Hadi. Zainab, your answer also help you to score only 1 mark. Abdul Hadi, your answer will help you to score 2 marks. Very good. So you have to write, it's 2 marks, so you have to write 2 things. The most important thing that you guys miss is first, it's a giant structure, right? Only the giant structures has a high melting point. Yes. And then you will write strong electrostatic forces of attraction between oppositely charged ions. Yes, you can write it in one sentence as well. So you can write that there are strong electrostatic forces of attraction between oppositely charged ions present in a giant lattice. Yes, you can write a giant lattice as well. You can write a giant structure as well. It doesn't matter. Now, calculate the percentage by mass of phosphorus in calcium phosphate. Give your answer to two significant figures. See, 2 is bold, so you have to be very careful where when you are writing the answer over here. It must be in a two significant figures only. Okay, so the formula is Ca3PO4 taken twice. So if you see there are two phosphorus, so the percentage of phosphorus in it would be the AR of phosphorus is 31. So 31 times 2. And here you have to write the MR times 100. So if you calculate the MR, there are 3 calciums, which makes it 122 of phosphorus, which makes it 62, and 8 oxygens, which makes it 128. Yes, can anyone tell me the value of MR? 120, 240, 248, 250. Is it 300 or 310, I suppose? So I think 310. Yeah. So this is how you will do it. Can anyone tell me the answer, please? Is what percentage we are getting? Okay, thank you, Zainab. It's 20%. So see two significant figures. Now, question number 5. Ammonium chloride decomposes when heated to make hydrogen chloride and ammonium. Okay. The reaction is reversible. The forward reaction absorbs thermal energy. So see, it tells you that the forward reaction is endothermic because it is absorbing the energy. Yes, very good, Rahan. Okay. So it means that the enthalpy change for the forward reaction is positive and the enthalpy change for the backward reaction is negative. Is this clear to all of you? Okay. An equilibrium mixture is found when the reversible reaction happens in a closed system. Okay. State what is meant by the term equilibrium. Include ideas about the rate of reaction and the concentration of the reactants and products in your answer. So see, they have told you that in what way you have to explain it. Rate of forward reaction is equal to rate of backward reaction. Very good, Zainab. Yes, Rahim, very good. But your answer is half. Okay, you guys just give me a minute, please. Okay. So when we have to explain in terms of rate, we can say that the rate of forward reaction is equals to rate of backward reaction. And when we have to explain in terms of concentration of the reactant product, we will say that the concentration of reactant and the concentrations of the reactants and the products are constant at equilibrium. So I can write at equilibrium the rate of forward and backward reaction is equal, and the concentration of forward and backward reaction, sorry, concentration of reactants and products is constant. Okay. Now, next part. Predict what happens to the position of equilibrium when the temperature is increased and pressure remains constant. So remember, when the temperature is increased, where the equilibrium shifts. One more minute, please. So equilibrium always shift towards endo, and as they have told us, the forward reaction is endo. So it means equilibrium will move forward, will shift towards the right. Yes, very good, Moaz, very good, Rahim, very good, Zainab, very good, Mustafa, very good, Ahmed. So prediction will be that it shifts to the right, and the explanation will be because the forward reaction is endothermic. Is this clear to all of you? Now, predict the position of equilibrium when the pressure is increased. So remember, when the pressure is increased, equilibrium shifts towards the side where lesser moles of gas are present. Yes, 2 marks, 1 mark for the prediction and 1 mark for the explanation. Give me 1 minute, please. Yes, See, remember this, you need to remember this point. If the pressure is increased, equilibrium shift towards where the lesser moles of gas. And if we decrease the pressure, then equilibrium shifts towards the side where there are more moles of gas. So we have to see where the lesser moles of gas. So if you see, this is gas, this is gas. So on the product side, we have a 2 moles of gas, but on the reactant side, there is a no mole of gas. So it means the pressure is increased, so the equilibrium which is shift towards the left. Why? It is because there are lesser moles of gas or no moles of gas. Or you can write there are more moles of gas on the product side or less moles of gas on the reactant side. So it shifts to the left, and the explanation would be you can write lesser moles of gas at reactant side or at right or left side. Is this clear to all of you? Yes, it's yes, Rahim. No, you can't write just lesser number of moles on reactant side. You have to mention the lesser number of moles of gases, not just the lesser number of moles. We have to just see the moles of gases whether on right and left on reactant and product side. Okay. Now, B part. Predict what happens to the rate of backward reaction. Okay. When the temperature is increased and pressure remain constant. We know when the temperature is increased, what happens to the rate? Rate increases, so it doesn't matter. Here the examiner trick you whether it's a backward reaction or the forward reaction. If the temperature is increased, then the rate increases. Okay. Why it is increases? Because particles have more kinetic energy and hence greater frequency of successful collisions. Okay. Now, predict what happens to the rate of reaction when the pressure is increased and the temperature remain constant. So we know when the pressure is increased, what happens to the rate? Yes, on increasing pressure, what happens to the rate? It increases. Very good. It increases. How pressure increases, decrease the rate. The rate would decrease. We are increasing the pressure, right? We are letting the particles to be closer to each other. That's how the pressure can be increased. So if the particles gets closer, then obviously their frequency of collision would increases and the rate of reaction would increases. So again, rate increases, and the explanation would be now more particles in a unit volume, right? Because if we apply the pressure, the gas compresses, the molecules come closer to each other. So there are more number of particles in a unit volume. Hence, greater frequency of collisions, or the greater frequency of the successful collisions. So here we are ended with 5 questions. Now I think 6. 8, 9, 10. So this paper has a 10 questions. Now we will be continuing on Monday, and on Monday we are going to do the rest of the 5 questions. Okay. So see you everyone on Monday. Take care. Yes.